Okay, so we're going to start standard S2. We are most definitely not going to finish it today, but we are going to get a really good start on it, and we'll get far enough where we'll be able to practice quite a bit on Monday before we finish the notes Monday night. Alright, so I can solve quadratics by factoring. In Algebra 1, you worked on factoring quadratics. You did a whole chapter on it. It was one of your chapters at the very end. This standard is going to be a review of the learning that you did then, plus we're going to use those skills to factor any type of polynomial. Our main goal is factoring to find the x-intercepts. So when we factor, we are looking to find the x-intercepts. When you solve quadratics or any polynomial meaning many terms, so a quadratic has three, because we've been graphing quadratics, you can see that like standard form has three terms. So polynomial is anything that has three terms where your x is being raised to a power. But whenever you solve quadratics, you're finding where the graph would cross the x-axis. You are finding the x-intercepts, which can also be called the zeros or the roots. They're kind of all names that would identify the same things, the places where they cross the x-axis. Factoring is an essential skill in algebra, mainly because it builds on your ability to take a whole and break it down into its parts, which is actually math in general, and it is a skill that a lot of problem solving in real life utilizes. All that said, we all have to be very good at this standard when it's all said and done because it doesn't go away. There are a lot of quirky and weird ways to teach factoring. I will teach two main methods, but if you find another way or learn another way from another teacher, feel free to use it. I can't show them all, but you're welcome to use anything that works. Let's try some without a method. To show what we're actually doing and to start this discussion, we're going to review FOILing. Right? So we're going to multiply these two together. We'll start with that. So first terms, 2x times x gives me 2x squared. Outer gives me 4x. Inner gives me negative 3x. Last gives me negative 6. So I end up with 2x squared plus x minus 6. And then factoring is backing up the process. So FOILing is taking two binomials with parentheses and multiplying them together. Factoring is taking a quadratic that's in standard form and then backing up the process. So we're going to, you'll see the method that we're going to use kind of goes backwards in those steps. So when you factor, you're trying to break it up into its parts. So we usually end up having to break up that middle part into two things that make it up. In the method that we use, we look for two numbers that multiply to get, like what these would be multiplied, so negative 12. And then add to get the middle number, which is 1. So it would be 4, negative 3, because they multiply to get negative 12 and add to get 1. And I know that was probably confusing, so it'll make more sense when we actually do a problem later. But it's working from here to the middle step to where you get the two factors that make it up. So factoring is doing the opposite of FOILing. It's starting with something like this and getting it to where you have two parentheses with two terms each. You'll notice that this expression, so 2x minus 3 times x minus 2, is the same thing as this and vice versa. There's just two different ways to write a quadratic. If you can factor a quadratic, it becomes very, very easy to solve. We've already been working with solving stuff in intercept form, something that looks like this, per se. Because they've taken something that is in standard form and they've rewritten it in terms of its factors. So they've factored it. And then to find our x-intercepts, we just took both those and set them equal to 0. So factoring makes solving for your x-intercepts very quick and easy. When you factor, what you're taking, or what you're doing is taking the whole and finding the parts that you had to multiply to get that result. So it's essentially backing up the process or unfoiling. We're going to focus first on quadratics for your comfort level and then look at how we can expand to every polynomial in the next units. We're not going to deal with it in Unit 2, but you'll see factoring getting Unit 3. So, for example 1, factoring without a method. Oh, I forgot to write down. Let's start with, sorry, I just have to do a quick problem here. Okay, let's start with this problem. 10x squared plus 13x minus 3. Okay, so if I wanted to break this apart, so this is my whole, and I want to break it up into the two parts that I would have to multiply or FOIL together in order to get that whole, one method that you can do is guess and check. I don't recommend that method if you have another method that works because sometimes guess and check takes quite a long time. For example, when you're FOILing, you have to be able to take this term and this term, multiply them together to get your first. Like that's what we did here. We multiplied 2x and x to get 2x squared. So we'd have to multiply this and this to get 10x squared. Well, you could break it up into 10x and 1x. You could break it up into negative 10x and negative x. You could break it up into negative 5 and negative 2x. And you could break it up into 5x and 2x. Like there's so many options there that would get you multiplied to 10x squared. The other thing with FOILing is you have to be able to multiply your last terms and get the last number in your equation. So negative 3 times 2 up here gave me negative 6, which means these two numbers have to multiply to get negative 3. Okay, so you could have negative 3 and 1. Okay, well if you were to FOIL this together in our heads, you get 10x squared. Outer terms would give you 10x. Inner terms would give you negative 3. Well, 10 minus 3 does not get me 13, so this one's out. We could do plus 1, negative 3. 10x squared. Out here you get negative 30 minus 1, so negative 31x. That's not what I have either, so that's out. And then you could test this. You get 10x squared minus 5 minus 6, so that gives me negative 11. Still not. And then let's try this. 10x squared plus 15x minus 2x. Well, 15x minus 2x does get me that 13. So that's my solution. These two parts, if I FOILed them together, would get me my original quadratic. But notice that, 10x squared, that broke up. But what if you had 12? Well, 12 can be broken up into 12 and 1, 4 and 3, 2 and 6. So you'd have even more choices for guess and check. So even though guess and check is you can figure it out with that method, it's not necessarily the most convenient because it takes time to do. So we're going to practice this a little bit more tomorrow for warm-up, but that is guess and check. Is where you try to figure out, okay, well I know this times this has to give me 10x squared, so you write all the options. And then this times this has to get me negative 3, so I'm going to write all my options until I can FOIL something in my head to match what I had originally. It just takes a while. So then we go to steps to factoring a quadratic, and this is the actual method that I teach. Again, there's multiple methods, so if you've had another teacher who taught you how to factor some other different way, that's fine. You can use that. It'll work. As long as we get to the same result, that's all I really care about. Okay, so steps to factoring a quadratic method. You're going to first move everything to one side, set it equal to 0. This is only needed if you have an equation. So if there's an equal sign in the problem, then move everything over to one side and get it equal to 0. This part, pull out the greatest common factor, you're definitely going to have to pay attention to for every problem, whether you have an equation or you don't. Greatest common factor is the number that goes into each number that you have. And sometimes you don't have one, and that's okay. After you pull out the greatest common factor, you're going to multiply A and C together and write that value off to the side. Okay. After you multiply A and C together, you're going to determine two numbers that multiply to get that value, and by that value, I'm talking about that number that you wrote off to the side. Oh, sorry, I'm grabbing a book right now. Okay. Determine two numbers that multiply to get that value, so whatever A times C was. And they also, so they not only have to multiply to get that value of A times C, they also have to add to get your value for B. Okay. Fourth step will be to replace Bx with those two numbers. And the final step will be to factor by grouping, which means group first two. I should mean group the first two parentheses, group your last two parentheses, and pull the GCF, or the greatest common factor, out of both. Okay. To solve, if equal to 0, take both parentheses, set equal to 0, and solve. And I think, yeah, just leave it like that. Now, I know that that's a lot of writing. I know that probably half of that didn't make sense yet. The reason we're writing it in your notes right now is so that we have something to refer back to as we start working on some examples together. But really, it's the process of the examples that we're going to be practicing here. So I think we have time to do two of them. Let's start with this one. 3x squared plus 8x minus 3. We're just going to work on factoring. I'm going to walk you through each one of these steps. Then you have a list to refer back to. Alright, we first look to see if there's a greatest common factor. There's no greatest common factor here because there's no number that goes into 3, 8, and negative 3 except for 1. But we're not going to pull out a 1. So the first step is done. Second step is to multiply your A and C together. So 3 times negative 3 is negative 9. I put that number off to this side. Now I'm looking for two numbers that multiply to get negative 9 and add to get 8. So negative 9, well, I could do negative 3 and 3, but those don't add to get 8. I could do negative 9 and 1. Those don't add to get 8. Or I could do 9 and negative 1. Okay, those two do add to get 8. So you replace that middle term to get that expression, 3x squared plus 9x minus x minus 3. you're basically unfoiling. So you know, like over here when we foiled and you get those inner and outer terms that you have to add together, we're basically breaking apart that middle term right now into the two parts that made it up. And then we factor by grouping. So you group the first two, and we group the last two. You pull out the greatest common factor out of each grouping, so the number that goes into both 3 and 9 is 3. There's two x's here, one x here, so I can pull out a 3x. Now if you're not sure you did it correctly, you can redistribute in your mind to see if you get the same thing, which you would here. In this other parenthesis, I'm going to pull, if you have a negative right there, you're going to at least pull out a -1. Now, in order for factoring by grouping to work, or to know if you did it right, these two parentheses have to be the same. Because your final answer should only be two binomials, right? Two parentheses multiplied together. Your first parenthesis is going to be your greatest common factors that you pulled out, put into one parenthesis. And you're just going to write the repeated parenthesis once. Now check and see if you did it right. We'd FOIL together. So 3x times x gives me 3x squared. Outer gives me 9x. Inner gives me -x. And last gives me -3. So I do indeed get what I started with. Those should match. Okay, we're going to do one more together, I think. Yeah. So we'll do example 4 together as warm-up on Monday. Okay, well, the next one we're going to do is going to be 6x squared minus 33x plus 15. I'm going to walk through the same process again. Your first step is to pull out the greatest common factor. 3 is the greatest common factor here because 3 goes into 6, 33, and 15. So I'm going to pull out a 3. And we'd be left with 2x squared minus 11x plus 5. Because basically what you're doing here is you're dividing each of these numbers by 3. And then when you factor, like when you multiply a and c together, you kind of ignore the greatest common factor you pulled out and just deal with the numbers inside the parentheses. So that's what we're going to do from here on out. We multiply a and c together to get started. So 2 times 5 gives me 10. I'm looking for two numbers now that multiply to get 10 and add to get -11. So we need, looks like -10 and -1. Multiply to get +10, add to get -11. Those two numbers replace the middle term that. We factor by grouping, so you group the first two, you group the last two. Because we're unfoiling, we're unpacking this quadratic to get what we started with. The greatest common factor out of the first grouping is going to be a 2 and an x, because you have 2 x's here, 1 x here, so I can pull one out. I'm left with x minus 5. Then over here, if there's a negative, pull out a negative. And all that does is change the sign. You can always just double check to make sure if you redistributed, you get what you started with. Your final answer is your greatest common factors put together into one parenthesis and your repeated factor written once. And again, we can check by FOILing. First would give me 2x squared. Outer gives me -10x. Inner gives me -x. And last gives me +5, which would get what I started with, because remember that 3, that should actually be in my answer there, because then if I multiplied everything by 3 here, I would get what I started with. So, alright, if that was confusing, I recommend at least going back and rewatching example 2 and example 3, and then we're going to practice this a lot Monday, Tuesday, Wednesday, and Thursday before your test on Friday. Alright, that's it.